Hi, this is Alix Paultre, and I'm here at the APEC show in San Antonio, and I'm here with my very good friend Andy and from Power Integrations. Hi, Andy.
Hello there.
Well, we've talked many, many times, and I remember when you first briefed me on the InnoSwitch 3, and I was very, very lucky and pleased that you gave me a sneak preview on this new product last week at Embedded World, but I'm really glad we have a chance to do a live demo for our audience. So why don't you tell us a little bit about this?
Sure. Well, InnoSwitch 3 Pro is a development of our InnoSwitch 3 technology. We're now putting an I2C communication bus into controlling the switching of our power conversion IC. And this makes the IC itself very powerful. We can now control output voltage, output current, we can control protection features, whether they do shutdown, auto restart, which protection features are turned on, which are not. We can also give feedback from the power supply to the microcontroller, telling it what the power supply thinks it's doing. So now we have telemetry monitoring, and we have just the ability to change lots of things. And what the demonstration today is showing is a somewhat light-hearted way of showing all the things we can modify on a power supply.
Well, then show us, please.
Okay, so what we have here is a display showing what's going on an oscilloscope, and that's mapping. If we should just show you down here. We have two power supplies using the InnoSwitch 3 Pro. One of them is giving a constant current output, and one of them a constant voltage output. So, okay, the controller is a little Arduino board powering an I2C bus onto these devices. What that allows us to do is control current on one channel, voltage on the other channel. And this is what we're showing up here. So we have one power supply showing output voltage and another power supply showing output current. And because this system was programmed by one of our millennials, everything's controlled from an iPad through a Bluetooth connector. So initially, if I want to change the output voltage in real time on the power supply, it's as simple as just adjusting a slider. We'll see the output voltage change. And you can see we can change this dynamically. We can move it all over the place. A range of somewhere between 3 volts and 24 volts. That's a wide range of control. We can also adjust the current on a constant current application. So you can see the blue trace, just by sliding up and down, I can do that. And that's kind of boring. So to take it a little bit further, what we did is we compared the output voltage to the output current here. And first of all, we can create by changing the waveforms on the output. So now we're going from a dynamic DC to a dynamic sine wave output. We're now creating some Lissajous figures that everybody who's ever done engineering understands. Difference being, this is being done with a 20 volt output and a 5 amp power supply, not with the microvolts you get out of a signal generator. So this is really cool. And because we gave this to our applications team and their engineers, and they always do more than we ask them to, they came up with some fun other changes by precisely controlling this waveform and this waveform. So voltage and current, now we're programming them in real time. We can create the PI logo to demonstrate exactly what the IC is capable of. And because we were showing this at a press dinner with a lot of Alix's colleagues last night, not Alix obviously, because Alix is a very clean living young man, we were able to do something that would also appeal to the journalistic group that we were talking to last night. So really, it's kind of fun, but what it's showing is that we can control output voltage and output current
Very precisely.
accurately in real time. So that's what our demonstration today is showing.
Very cool, Andy. I really appreciate it. And this is a very fun demo. Well, and the point is, it's the precision, the accuracy and speed. You couldn't draw those Lissajous without that.
Yeah, it's showing that we can do 10 millivolts resolution, 50 milliamps resolution on the output. It's great for our customers because it now means post-regulation is not required. For rapid charging, obviously it's got functionality. There's a lot of areas it's going to go into that we haven't even thought of yet.
Well, that's the nice thing about engineering is you show an engineer a device and you'll get applications you never thought of.
Exactly, that's what we're getting already.
Very cool. Thank you so much, Andy, for showing us this at the show.
Thank you very much.